Let me introduce you to Power Capacity in StructureWare Data Center Operation version 8.0. In StructureWare Data Center Operation version 8.0, capacity calculations are not based on predefined groups. Instead, capacity is defined by the power path, which is the capacity of the supplying UPS, any breakers, including derating, and eventually the rack PDU. Racks with the same power path will have an identical capacity. You can also set up a design limit, which we demonstrate later on in this video. In this video, we'll be covering capacity limiting factors, UPS and breaker limits, design capacity, and capacity in a 2N setup. Let's build a simple power path and examine the capacity. Every UPS has some physical capacity, which is shared between all the connected devices. Next, I will add the floor PDU. I will connect the PDU to the UPS. PDU capacity is the same as on the UPS. Let's introduce an input breaker to the PDU. The input breaker is limiting the floor PDU capacity. The UPS supply of 400 volts is divided by 3 phases and multiplied by the breaker rating and the derating. Now, let's define the power capacity for a rack by establishing its power path. I will add a rack PDU and specify how it's connected. There is a breaker on the power panel, which is defining the capacity of the rack PDU. Rack capacity is limited by upstream breakers. Now I'm going to add a server to the rack. Notice that the capacity reduced for all 3 phases, as a precaution until the server connection is defined. By specifying the server connections, I can improve the capacity calculations. Now the server's load is only applied to phase 1. Let's add another rack PDU to increase the number of sockets. The second rack PDU is connected to the same power panel on the same floor PDU. It also has the same sized breaker. The only available breaker positions are shown in the menu. The rack capacity has increased since the load is now shared by 2 breakers. But I didn't want this. I only needed more sockets. To avoid placing too much load on this rack, I can impose a design limit on the rack. A design limit reduces rack power capacity without affecting any other properties. The design limit feature appears in the rack tooltip in Power Overlay. And that's a quick look at power capacity and placing a design limit on power. Now the rack we see here is supplied by 2 feeds, suitable for 2N redundancy. Let's add a server with 2 power inlets. Notice that the power load is overestimated until we specify connections. This server is connected in the 2N setup, using the same phase on 2 rack PDUs. In case of one of the power feeds failing, all the server load is transferred to another feed. And this is the potential failover load. Let's add a server with a single power inlet. Any additional load will apply to all phases on both PDUs, leading to a very low estimate. I need to specify the PDU and a phase connection manually. Let's take a look at the remaining rack capacity. The green area shows the remaining 2N capacity. Blue is the additional non-redundant capacity. This is a fairly inefficient use of a 2N rack, but the power capacity is still calculated correctly. We looked at power capacity calculations in the 2N setup. However, what if there is no UPS? What if my second feed comes directly from the power grid? No UPS? No problem. Notice how the power path color changed to white. Floor PDU capacity did not change at all, because there is an input power breaker specified on the PDU. This input breaker is your breaker from the mains or the power grid. The rest of the power path remains the same.